Welcome to Automotive Basic Knowledge. Our topic for today is about fuel injector operating principles and diagnostics. In this discussion we covered Introduction of fuel injector, fuel injectors types, A. Fuel injector for single-point injection system, B. Fuel injector for multi-point injection system, fuel injector impedance, fuel injector voltage and current signals, the voltage and current waveform at high impedance injectors, the voltage and current waveform at low impedance injectors, diagnostics and testing procedures, electrical diagnostics, fuel supply diagnostics. Introduction of fuel injector. The electronic control unit determines the precise amount and specific timing of required gasoline dose for every cycle, by collecting information from various engine sensors. So, the ECU sends a command electrical signal of the correct duration and timing to the fuel injector coil. In that way opens the injector and allows petrol to pass through it into the engine. The one terminal of the injector coil is directly supplied by 12 volts, which is controlled by the ECU, and the other terminal of the injector coil is open. When ECU determines the exact amount of fuel and when to inject it, activates the appropriate injector by switching the other terminal to the ground. Fuel injector types. The figure 1 under A shows a typical build of a fuel injector for single-point injection system, and under B shows typical build of a fuel injector for multi-point injection system. A fuel injector for single-point injection system. 1 fine petrol filter. 2 electrical coil. 3 returning spring. 4 electrical connector, fuel outlet. 5 armature. 6 ball valve. In single-point injection system is used only one common injector, which is located before the throttle and injects the fuel for all cylinders. These types of injectors are usually with relatively lower impedance. B. Fuel injector for multi-point injection system. 1 returning spring. 2 fine petrol filter. 3 electrical connector. 4 electrical coil. 5 armature. 6 needle valve. In multi-point injection system is used 1 injector for each cylinder. The injectors are located after the throttle, and are positioned so that they point at the back of the inlet valves. These types of injectors are usually with relatively higher impedance. Fuel injector impedance. According to the used injection system type, usually there are 2 general impedance ranges for the injector coils. High impedance injectors are generally used in multi-point systems and they are with an impedance in the range of 12 to 18 ohms. Low impedance injectors are generally used in single-point systems and they are with an impedance in the range of 0.5 to 2.5 ohms. Fuel injector voltage and current signals. The voltage and current waveform at high impedance injectors. Voltage signal. At point A, the injector is off. At point B, the ECU turns the injector on, by bringing the ground, mass, to the injector coil, so at point C the voltage drops to 0. At point D, the ECU turns the injector off. At this point there is an amount of stored energy in the injector coil, so a large back electromotive force is generated which causes a large voltage spike at point E. This voltage is fast dissipated by the impedance of the injector coil and quickly returns to 12 volts at point F. Current signal. At point A, the injector is off. At point B, the ECU turns the injector on, so at point C the current increases through the coil. When the magnetic field becomes strong enough to overcome the internal spring and fuel pressure, the needle lifts which produces a small dip in the current near at point D. The ECU turns the injector off at point E, so the current returns to 0 at point F. The voltage and current waveform at low impedance injectors. Voltage signal. At point A, the injector is off. At point B, the ECU turns the injector on, by bringing the ground, mass, to the injector coil, so at point C the voltage drops to 0. When the ECU determined that the current flow is high enough to lift the needle, turns the injector off at point D. The stored energy in the injector coil causes the large voltage spike at point E, then the ECU pulses the injector on and off, faster than the injector can react, so the needle floats in an open position during F. When enough amount of fuel has been delivered, the injector is turned off. This produces a large voltage spike which immediately falls to 12 volts at point G. Current signal. At point A, the injector is off. At point B, the ECU turns the injector on, so at point C the current increases through the coil. When the magnetic field becomes strong enough to overcome the internal spring and fuel pressure, the needle lifts which produces a small dip in the current at point D. To prevent overheating, the ECU starts to pulse the injector at point E. The pulses continue during F, and after the final pulse, the current returns to zero at point G. Diagnostics and testing procedures. Electrical diagnostics. Unplug the injector connector and check the impedance of injector coil with multimeter. For a low impedance injector, the reading should be in the range of 0.5 to 2.5 ohms, and for high impedance injector should be in the range of 12 to 18 ohms. If the reading drastically deviates including zero or infinite, replace the injector. When the ignition is turned on or while engine cranking, check that there is 12 DC volts power supply on the terminal of the injector with respect to battery negative pole. While engine cranking with oscilloscope or LED lamp, check the electrical signal to the injector with respect to battery positive pole, since the ECU controls the ground of the injector coil. The LED lamp should fast blinking according to the engine RPM. Check the operation of the control relay if applicable in the system. Check the continuity and condition of all electrical connections, injector terminals, wires from the injectors to the ECU, etc. Fuel supply diagnostics. Check the fuel system pressure. Typically the value of fuel pressure should be around 1 bar, but at some MPI systems the working pressure can reach in 3-4 bars. Check the condition of the vacuum hose to the fuel pressure regulator. Check the operation of the fuel pressure regulator. Check the injectors for any leaks or mechanical damage. Check the condition of the rubber O-ring seals at the lower end of injector. Check the condition of the rubber O-ring seals at the upper end of injector. Check the wideness of dispersion angle of fuel injection. Check the injectors for any dirt and combustion deposits around the nozzle. If you enjoying reading and watching of this video, click the like button or provide your comment below. Thank you.